All right, let's talk about light. Today we're diving into the amazing physics that explains how light zips around our world. We're going to look at everything from a simple reflection to the wild way it seems to bend when it travels through stuff like water or glass. So let's get right into the science behind what we see every day.
You've totally seen this, right? You take a perfectly normal straight pencil, stick it in a glass of water, and bam, it looks like it just snapped in half right at the water's surface. So what's the deal with that? It's not a magic trick, I promise. It's pure physics. And by the time we're done here, you'll know exactly how that illusion works. Okay, so before we can get to all the cool bending and bouncing, we have to get one thing straight. Literally. The number one rule of light is that it travels in a perfectly straight line, as long as it's moving through the same stuff, like air or empty space. This is our baseline. It's only when light hits something new that the real fun begins.
So first up, reflection. What happens when that straight beam of light smacks into something it can't pass through, like a mirror? Well, it bounces off. This is what we call reflection, and it follows some really neat and tidy rules.
Yep, that's the official definition. Reflection is just what happens when a light ray hits a surface and bounces off, changing its direction. The best way to think about it, imagine throwing a tennis ball against a wall. It flies in, hits the wall, and bounces right back out. Light does the exact same thing. And here's the cool part. That bounce isn't random at all. It follows one simple, unbreakable rule. The angle that the light comes in at, we call that the angle of incidence, is always exactly the same as the angle it bounces out at. Always. It's not just a guideline, it's a fundamental law of physics.
Of course, not all mirrors are flat, and when you start curving them, you can do some really cool tricks with light. A concave mirror curves inward, kind of like the inside of a spoon. It takes all the light rays and brings them together or converges them. But a convex mirror, which bulges out like the back of a spoon, does the exact opposite. It spreads all the light rays apart. This is why funhouse mirrors make you look so wacky.
Okay, so we've got the whole bouncing thing down. But what happens when light can pass through something, say from the air into a pool of water? Well, that's where things get bendy. This is called refraction, and it's the real secret behind our broken pencil mystery.
Yep, refraction is the official term for the bending of light. It's the second big behavior we're looking at today. Anytime light goes from one transparent material or medium to another, it changes direction. It actually bends. So why? Why does light bend? It all comes down to one simple thing, a change in speed. See, light doesn't travel at the same speed through everything. It's super fast in a vacuum, a tiny bit slower in air, and even slower in water or glass. So when a ray of light hits a new material at an angle, one side of the ray slows down before the other, which causes the whole thing to pivot or bend.
And the way it bends is totally predictable. When light moves from a thinner material like air into a denser one like water, it slows down and bends towards an imaginary center line. But when it goes the other way, from dense to thin, it speeds up and bends away from that line.
This classic experiment shows it all in action. You've got a ray of light hitting a block of glass. First, as it enters the glass, it slows down and takes a turn. Then, it travels in a new straight line through the glass. Finally, when it pops back out into the air, it speeds up and bends again, but in the opposite direction. The ray comes out parallel to where it started, just shifted over a bit. Now, this isn't just stuff for a physics textbook. Not at all. Bouncing and bending light, reflection and refraction are happening all around us all the time. They're literally the reason we see the world the way we do, and they're the secret behind some of our most important inventions. So, let's circle back to that pencil. The light coming from the part of the pencil that's underwater has to travel from water to air to get to your eyes. As it does, it bends. This makes it look like it's coming from a shallower spot, which is why the pencil looks broken. It's the same reason a coin in a fountain looks closer than it really is. And of course, things like eyeglasses, cameras, and telescopes are all designed specifically to bend light in just the right way. And just like we have curved mirrors to control bouncing, we have curved lenses to control bending. A convex lens is thicker in the middle, and it converges light rays, bringing them to a point. A concave lens is the opposite. It's thinner in the middle, and it diverges or spreads light rays out. By combining these two types, we've been able to build everything from microscopes to giant telescopes. Okay, so let's do a quick recap. Reflection is the bounce. Its key tool is the mirror, and it follows that simple angle in equals angle out rule. Refraction is the bend.
Its key tool is the lens, and it happens because light changes speed when it enters a new material. Bounce versus bend. Pretty straightforward when you break it down, right?
And that just about covers it. We've seen how these two simple rules for light, bouncing and bending, are responsible for so much of how we see and interact with the world. It really makes you think, doesn't it? If the very light we see can be bent and fooled by invisible boundaries, what other powerful unseen forces might be shaping our reality right in front of our eyes? Thanks for tuning in.